Okay, so welcome to week 8 here, and we're going to try a little something. I've been not having as much energy, it could be the summer heat or whatever, but my wife has made me this tea right here, and this tea is a traditional Korean tea, so I'm not sure if you can hold this up here a little better, see the ingredients there, but lots of roots and herbs and uh, funky things that probably don't even have an English name. So the question is, will the tea actually work? And even if I'm drinking it, how do I know if it's working or not? So that's what we can use inferential statistics for. Now, without inferential statistics, this would be an incredibly hard question to figure out. Because really, if you think about it, we have a population of my life. Every day is an individual unit in the population of all the days of my life. And so what we can do is take a sample. Since there's no way we could study every single day in my life, what we can do is study the effects within a small portion of my life, a small sample of those days. But we still need some way to tell whether it's the tea working or whether it's some other factor in my life that's giving me energy or sapping my energy. So what we're going to do is go through a real quick inferential statistics test. We're not going to do the actual numbers, but just get the concept of what's going on here. So I have this, actually I have a research hypothesis first. The research hypothesis is that the tea gives me more energy throughout the day. Okay, this is a one-sided hypothesis. What that means is I'm saying the effect will be in a certain direction. A two-sided hypothesis would be something like the tea has an effect on my energy, but I'm not saying whether it gives me more energy or gives me less energy. In either case, the null hypothesis is that the tea has no effect on my energy level. So when we set up the research hypothesis and the null hypothesis, we want them to be so that one of the two will be true. One of them should be true. Now in this case, when you have a one-sided test, there is the possibility, I guess, that the tea could reduce my energy level, which is why on a one-sided test, you usually don't use that unless you're very confident that if there's an effect, it'll be in a certain direction, or potentially, if there's a negative effect, you don't care about it at all. It's just as bad as having no effect, which is the case in this. If this has a negative effect on me, it would be the same as having no effect. In either case, I just wouldn't want to drink it. So, how do I decide whether to go with the null hypothesis or the research hypothesis? Well, what I'm going to do is take a random assignment. I'm randomly going to assign my days to tea or not. Now, how am I going to do that? I've got a coin, and if I flip a heads, I'll drink the tea that morning. If I flip a tails, I don't drink a tea that morning. And then each evening, when I come in the door after work, I'll rate my energy level on a scale of 1 to 5, 5 being lots of energy, 1 being very little energy. So flip it, get a heads, drink the tea, have my day at work, come back, come in the door, maybe I feel 4, feel decent amount of energy. Maybe the next day, flip it, also get a heads. Remember, short-term randomness is pretty crazy. I could have five days in a row where I flip a heads. But whatever the case, I'm going to rank it. And then after 60 days, I'm going to get about 30 of each, although we know that it won't be exactly 30. It probably won't be exactly 30 of each. But after 60 days, I'm going to cut the experiment off, and I'm going to average the energy level that I felt from the tea drinking days and compare it to the average energy level I felt from the non-tea drinking days. So let's think about this. In my case, I'm actually looking for a causal effect. I don't just want a correlation. I want to know, is the tea actually giving me energy? And we'll talk about this a little bit later when we get into cause versus correlation. But for now, know that random assignment is the key to showing a causal effect. If you don't have random assignment, it's very difficult. It's not impossible, but very difficult to show that something is causing something else. For example, T is causing me to have a higher energy level. So, randomly assigning the days, how does that help? Why does that even matter? Why don't I just say day 1 I drink the tea, day 2 I don't, day 3 I drink the tea, day 4 I don't? That would be a systematic sampling. Well, the problem is there could be lots of other things affecting my energy level, right? So, for example, maybe some days my level of stress at work isn't as high. Maybe I'm not talking about inferential testing and trying to explain that. On other days, maybe my kids are a little bit more wound up than other. There could be so many different things affecting my energy. So the question is, how am I going to pinpoint that it's this T and not one of those other things that's affecting my energy level? If you've ever heard of noise and signal, noise is all the variance that's coming from things other than the T. For example, my kids' level of energy that day, or the stress level at work, maybe if I pray or not pray that day, if I have some kind of food that I ate that morning that gave me a lot more energy. All these things are noise, and they're going to drown out the signal that I'm looking for. So in theory, I want the noise to be very small and the signal to be very loud. Does this remind you of anything? Remember a couple weeks ago when we talked about variation, I want the between group variation to be very large. That's the signal. So the between group here, the two groups are the tea drinking days and the non-tea drinking days. I want those to be very different. The more different they are, the more likely it is that I am to see that difference. On the other hand, within group variation, within the tea drinking days or the non-tea drinking days, that noise I would like to be small. I would like that within group variation to be small. And what that will do is it'll give me a smaller standard error, and it'll make it more likely that I'll pick up that effect, if there really is an effect, from drinking the tea. Okay, so I've gone through this all. I've done the 60 days, I've got all my averages. I run through the formulas. What the formulas are actually doing, they're telling me what I get when I get a difference. So for example, the average of the days when I drank the tea, let's say it was 3.5, and the average of the days when I didn't drink the tea, let's say it was 2.9. So I subtract those two and I get 0.6. But what does that mean? Does that really mean that in the population of the days of my life, for example, in general, not just during the sample of the 60 days I looked at, but in general in my life, is the tea really giving me energy? Not necessarily. Just because something shows up in your sample does not mean it's true for the population. Absolutely not. That's why we have to do an inferential statistics test. We have to see if that difference is really significant. And we do that in a couple different ways. So for one, we calculate what's called a t-statistic for the sample. But before we even do that, we set up what's called a critical region. On a one-tailed test, it'll look something like this, where you have all the critical region on one side. On a two-tailed, it'll look something like this, where you kind of split it across. How big do you make that? That's up to you. That depends on your alpha level of significance. Okay, this is typically going to be 0.05. So typically that shaded portion will be 5% of your graph, whether it's all bunched up on one side or split up 2.5, 2.5. Your alpha level of significance will often be 5%. It doesn't have to be. In some medical tests, it might be 1%. What this is, it's the risk of making a type 1 error. Now, what's a type 1 error? So remember we had this null hypothesis and this research hypothesis. A type 1 error would be if I reject the null. So going through all my things, my test, I end up, what would happen is I would get in this critical region with my t-test statistic. If that happens, I'm going to reject the null. We'll say that we've got pretty good evidence that this thing is not true. In other words, leaving me with the alternative that the tea does give me more energy. But just because I do that doesn't mean it was correct. Whenever you do inferential statistics, there's always a chance that you made an error. So in this case, if I ripped up this null hypothesis because I said my evidence shows this isn't true, that probably not true, that my p-value was lower than my alpha level, my t-test statistic was in that critical region up there, but I was wrong. Really, the tea has no effect. Even though I'm suggesting that it does have effect, maybe it doesn't have effect. If so, I just made a type 1 error. Okay? Type 1 error is rejecting the null when you shouldn't. Now, there's another way I can make an error. Let's say that my t-test statistic doesn't make it into this critical region, that I end up somewhere in here, in the non-shaded portion. In other words, my p-value was higher than that level of significance I was looking for. Maybe my level of significance is 0.05 and my p-value is 0.06. So what I do is I don't accept the null. So we never really accept the null, but I can't reject it. I can't rip it up. And I certainly can't conclude the research hypothesis. I don't have good evidence for that. But I failed to reject this. Now, it's possible that even though I did that, the tea really is effective. It's always possible. Maybe because of the sample I had, maybe because there was too much noise. For whatever reason, it's possible that the tea really is effective, but I couldn't reject my null hypothesis during my test. If that's true, I made a type 2 error. So no matter what I decide, it's possible that I made an error. If I reject the null, maybe I made a type 1 error. If I fail to reject the null, I could have made a type 2 error. So these are the two big errors we're going to talk about in this week. Now there's other errors that we're also going to look at a little bit. For example, generalizing. Just because I get my results for the study, remember that it doesn't prove anything. Because there's always the chance of one of those two errors, you never prove something with inferential statistics. But we feel confident. We feel if we have an alpha level of 0.05, we feel fairly confident that what our results are true. Now I need to be a little careful there. Well, we're going to talk about that alpha level and p-value more next week and what it exactly means. But suffice it to say, you cannot prove anything with inferential statistics. We can only suggest. Now the other thing I can do is generalize it wrong. So let's say I do indeed find that this tea, I reject the null and find that it's effective for me. Doesn't necessarily mean it's effective for you. Maybe it's designed on my body type. In fact, I do believe that these specific ingredients were chosen for my body type. So just because it's true for me doesn't mean it's true for you. This is the question of generalizing. The sample that we're looking at was taken from a population. If we try to put the results to a different population, suddenly it may or may not be true. We don't have nearly as much statistical evidence. That's that problem of overgeneralization, generalizing the results to a population that we really haven't looked at. Or if our sample is not really representative of our population. For example, if we didn't take a random sample, which I didn't, notice I did random assignment, so I flipped the coin to see where I would end up with each day, and that randomly assigned each day to tea drinking or not, but it didn't necessarily take a random sample of the days of my life. That would be impossible. And so even when I get results, I don't truly know if this sample of days is representative of all the days of my life. Maybe my health later on will be affected differently by the tea than now. So let's end with a coin flip to see if I drink it today or not. Heads I do, and it's a heads. So I've got to go pour my cup of tea and see what my energy level is today. All right, see you later.